We're going to go ahead and take a look at number 41 from section 4.2. And this is going to be a population growth problem. If you do not have your book right in front of you, what I would suggest doing is pausing the video and going ahead and grab it so that you can follow along. Also make sure that you have something to write with and something to write on so that you can jot down any important information that we come across as we read through the problem. So 41 reads, in 1999, the male population of the United States was about 133 million, and the female population was about 139 million. Assuming a Malthusian growth model with a 1% annual growth rate, how many more females than males will there be in 20 years? So the first thing that we need to note is that they're saying that there is a Malthusian growth model. So your textbook describes it as P is equal to P sub 0 times E raised to the K times T. But as I've stressed in class before, this is essentially the same thing as your continuously compounding formula. Really, they are one and the same. I've just switched the outer packaging. So you can use either one. So with this problem, we are going to have to look at what is happening with the male population in 20 years and what is happening with the female population in 20 years. So we actually have a 2-in-1 problem in this situation. So for males, I'm going to say that this is A sub m, so the final amount of men in 20 years, essentially, what that notation is. Don't be afraid to, I guess, get creative with your notation as long as you're explaining what it means. So we know that their initial population is 133 million. You could very well extend this out and actually write out the literal 133 million. But since the units, in a sense, aren't changing between men and women, so basically men are measured in millions and as are women, I think it's okay that you can just assume that that 133 is 133 million. We're going to multiply this by E, our natural number. Our rate is 1%, so we're going to convert that to a decimal. So 1% is the same thing as 1/100th. And we are concerned about how big the male population will be in 20 years. We can mirror this same setup and find out what the final population for women will be in 20 years. So we know that they're going to start off with an initial amount of 139 million women. Again, they're going to be continuously growing. Their growth rate is also at 1%, and we want to know where they will be in 20 years. So if you were to evaluate these, so I would suggest going into your calculator and doing that. And again, if you go into your calculator, I'll model it for the male one here. The calculator is going to read 133. You can put times in there, E, your little caret, and then 0.01 or 1/100th times 20. And make sure you have that 1/100th times 20 within some parentheses so that the calculator knows that that is what your exponent will be. Okay. If we were to go ahead and evaluate this, the final number of men at this point, I'm going to round this to the hundredths place, is going to be about 162.45 million men. And then if we did the evaluation for women, the final amount of women would be 169.77 million. And we want to know how many more women there will be than men. So intuitively, you can look at your final results so far and note that women are definitely populating more of the earth than men are. So also what we want to do is basically do a subtraction. So we're going to do 169.77 million minus 162.45 million, and it turns out that there are 7.32 million more women than men. If you were to check in your book, they're essentially going to round it to the nearest whole million. So since I have a 3 here, this is about 7 million more women than men in 20 years. Okay, I hope that that explains everything. Again, if you have any additional questions, please come see me.